Hey everyone, and welcome. Today, we're going to build the Internet of Things, starting from the ground up. We're going to see how you can go from a single blinking light on your desk to building real-world applications that could one day power an entire city. Let's jump in. Okay, so here's our game plan. We'll kick things off by looking at the technology that started it all. Then, we'll tackle the single biggest headache for anyone building IoT stuff. After that, it's time to get hands-on with a cool little computer called the Arduino, see how it interacts with the world, and finally, we'll zoom all the way out to see how these exact same ideas are building the smart cities of the future. All right, first things first. Before the whole Internet of Things thing blew up, we had something a bit more fundamental that really laid the groundwork. It's called machine-to-machine communication, or M2M for short. So what's the difference? Look, the easiest way to think about it is this. M2M is like a private phone call between two machines, using a dedicated line. It's a closed, one-to-one chat. IoT, on the other hand, is like a massive global conference call over the internet. It uses that universal IP network, so that literally anything and everything can join the conversation. At its core, M2M is just about one device talking directly to another, no humans involved. And while that might sound simple, it was a huge first step. It proved that machines could get things done all by themselves, planting the seed for the totally connected world we're building right now. And here's the crazy part. M2M has been quietly running our world for years. You know, when a vending machine tells a central server it's out of chips? That's M2M. When you use an ATM and it checks your bank balance? Yep, M2M again. It was kind of the invisible workhorse operating just under the surface of everyday life. So if M2M was working so well, why change it? Well, those M2M conversations were all private. To build a true Internet of Things, we had to solve a massive problem: interoperability. It's this huge challenge of getting billions of different devices, made by thousands of different companies, to all speak the same language. I mean, it seems like it should be easy, right? They're both smart, they're both on your Wi-Fi, but the reality is, it's a bit of a technological mess, like a digital Tower of Babel where every device is just shouting in its own unique language. And you can see why it's so complex. Your watch might use Bluetooth, but your smart thermostat uses Zigbee. One device is running code written in Java, another one's in Python. They might even represent the exact same thing, like the date, in totally different ways. Every single one of these layers is another wall, making communication almost impossible. And this right here is the holy grail: interoperability. It's this dream that any device can seamlessly connect and share info with any other device. Think about it. Your smartwatch detects you're waking up and tells your coffee maker to start brewing. That's the world interoperability makes possible. So how do we build a bridge over that Tower of Babel? Well, a key part of the solution is something called middleware. Just think of it as a universal translator. It's this clever piece of software that sits in the middle of everything, listening to all the different languages and translating them into one common format that everyone can understand. Okay, enough theory. Let's get practical. For all you engineers and makers out there, I want to introduce you to the awesome little tool that totally changed the game and made it possible for anyone to start building their own IoT devices. This little blue board is the Arduino Uno, and it is an absolute game changer. Why? Because it made hardware simple. Before the Arduino, just making a light blink required some serious electronics knowledge. Now, thanks to this board and its easy-to-learn coding environment, any B.Tech student or curious hobbyist can bring their ideas to life. Let's just peek under the hood real quick. Don't worry about all the technical jargon. The really important parts for us are the I/O pins, the input and output connections. You get 14 digital and 6 analog pins. That's 20 different points where you can connect sensors to read the world, or things like motors and LEDs to change the world. For just a few hundred rupees, this thing is the brain for almost any project you can dream up. So let's see how this all connects. An Arduino by itself is just a brain sitting in a jar. To make it do something cool, we need to give it senses to understand its surroundings and muscles to act on them. And the glue that holds it all together, that's code. You know, the code for an Arduino, they call it a sketch, is beautifully simple. There are really only two parts you have to know. First is setup. This runs one time, and one time only, right when you power it on. It's for getting everything ready. Then, the loop function takes over, and it does exactly what it says. It runs your main code over and over and over, forever. So the first thing everyone does is the blink sketch. It's the hello world of the hardware world. It's super simple. Hook up an LED, write a couple lines of code, and hit upload. I know it sounds basic, but trust me, that moment you see something in the physical world respond to your code, it's pure magic. And the heart of that code is this one simple command: digital write. It literally does what it says. You tell it which pin you're talking to, and then you tell it to write a digital signal, either high, which means on, or low, which means off. That's it. On and off. This one command is the building block for controlling almost everything.
But of course, IoT isn't just about turning things on and off. It's a two-way street. On one side, you have sensors. These are the Arduino's eyes and ears. They read data from the world, like temperature, light, or motion. On the other side, you have actuators. These are the hands. They act on the world, spinning a motor, making a sound, lighting up a screen. And the Arduino is the brain in the middle, making decisions based on what the sensors tell it.
Okay, take a breath. We have our little Arduino project, sensing and acting. Now imagine a dozen of these in your house. Then imagine 1,000 in an office building. Now, what happens when you take these same exact building blocks and apply them to an entire city? You get a smart city. The whole idea is to take that same sense, process, act loop that we just built on our desk and weave it into the very fabric of the city itself. Street lights become data points, water pipes become controllable systems, and the whole city starts to act like one giant intelligent organism. And this workflow, it's the exact same model, just on a massive scale. Instead of one sensor, you have millions collecting data. That data gets transmitted over citywide networks, stored in huge data warehouses, and then, this is the crucial part, it gets processed. Using analytics and prediction, the city can make intelligent decisions, like automatically rerouting traffic to prevent a jam before it even happens. Of course, this creates an absolute flood of data. And the real secret sauce for making sense of it all is a technique called data fusion. This is where you combine different streams of information to get a much bigger picture. You don't just look at traffic data, you fuse it with weather data, public event schedules, and social media chatter. By combining it all, you can create insights that are way more powerful than any single source alone. And this brings us to the final and most important question. The technical challenges of building a smart city are huge, for sure, but the ethical challenges are even bigger. As we cover our world in billions of devices that are constantly watching, listening, and learning, how do we make sure that power is used for good? How do we get all the benefits without sacrificing our privacy? That is the great challenge that your generation of engineers, builders, and thinkers is going out to solve.